All right, so now we're looking at inverse variation. All right, this is where when one variable increases, the other variable decreases. All right, graphically, it can be shown like this. All right, where we have our y variable and our x variable. So let me just illustrate a bit on inverse variation. All right, let's say, for example, we're all familiar with this formula. All right, density equals mass over volume. All right. Now, density and volume are there's an inverse variation between density and volume. All right. If volume goes up, density goes down. If volume goes down, density goes up. In this case, our constant is going to be mass. We'll say that mass will be held constant, right? Remember, in variation, we have our constant of variation. So in this case, our constant of variation is mass, which is represented by K, all right? Density will be represented by Y, and volume will be represented by X. So if we translate this to this graph here, if we say Y is density, and X is volume. As the volume increases, the density is reducing, holding mass constant. So the relationship for an inverse variation is Y equals K over X. So let's look at some examples. All right. So given that Y varies inversely oh, have I spelled inversely correct? Inverse, or there needs to be an E here, right? But anyway, inversely as X with X, all right, and Y equals 8 and X equals 14. All right. Find K, or constant of variation. So again, we are going to use this formula. Y equals K over X. In this case, Y equals 8, X equals 14. So we're going to kindly get your calculator. Right, so to get our value of K, we're going to say K equals 8 times 14. What is 8 times 14? Do you have your calculator near you? What is 8 times 14? Correct. Thank you for that. All right. Then let's say, for example, they tell us this is a continuation of the question. Find y if x equals 2. All right. So our constant is always going to be 112, right? So we say y equals k over x. K is 112. X is 2. 112 divided by 2. Can you give me the answers, Bongile? 112 divided by 2? 6. All right. Thank you. All right. So that is that about inverse variation. When one variable increases, the other reduces. All right. So this is very important for a lot of formulae that you're going to see throughout school, like for density, pressure, many formulae. All right. So once you have this knowledge about inverse variation, whenever you're using this formula in these other subjects, you should have an idea of how these variables are related.